Recently, Spring announced the Spring AI project, and it looks really promising. But it's in early alpha, and I don't want to wait that long. Let's see how we could add the OpenAI APIs to any existing Spring project using just the normal tools that come with Spring. Welcome to Tales from the Jar Side. This is the website for the reference manual on the Spring AI project, and you can see it aims to streamline development of applications that incorporate AI without unnecessary complexity. And specifically, they say they're introducing an AI interface with implementations for OpenAI and Azure OpenAI. That's all well and good, but here's the scary part. You see that? The version number is 0.2.0, snapshot no less. I think it might be a little while before it's ready for prime time. Instead, let's go ahead and access all of the OpenAI APIs in a regular old Spring project. This is the website for OpenAI's API. You can see it says, "Welcome to the OpenAI platform," and they talk about GPT to generate text and call functions. They talk about image generation using DALL-E, and they talk about speech to text, the Whisper model for transforming audio into text. All of these are available as RESTful web services, and from a Spring point of view, they're just another RESTful web service. For example, here's a Spring Boot test that I've already prepared. And if I want to get a ChatGPT response, all I have to do is create a request, and we'll talk about how to do that, and send in text and pick a type of message and a temperature and get back a response. And let's take a look at this in action. And you can see indeed, we get that the ultimate answer to the ultimate question of life, the universe, and everything is, of course, 42. How about DALL-E and image generation? Here is a test to send the message, a photorealistic image of a happy robot jumping up and down on springs. Let's take a look at that one. What you can see here is we generated 4 separate images and saved them to a directory. Here they are. That one's not bad. I'm not sure what's up with that spring. Okay, I guess. Yeah, I too can't wait for DALL-E 3 to come out and make all of this much better. Or how about the Whisper AI? This is a transcription service that's going to send a relatively small WAV file to be transcribed. And when I run this, it will return a transcription. And here's the resulting transcription. Search.j is so cool, I just have to tell somebody about this. I transcribed a YouTube short I made earlier in the year. Works just fine. Okay, let's see how to build this on our own. Let's start by making a new Spring Boot project using the Spring Initializer. I'll call it OpenAI Access. I'll put it in a directory on my disk. I'll write it in Java using the Gradle build tool with the Kotlin DSL. Let's change the group ID to com.cousinit.ai. I'm going to use Java 17 because first I want to use some features from Java 17, and secondly, the Spring Initializer on Spring 3 is going to require Java 17. So I then say next, and on Spring Boot 3, I'm using the current version, which turns out at the moment to be version 3.1.4. The only dependencies I need are Spring Web, and in case I want to add a controller, I don't even really need that, and Spring Reactive Web, which I am going to need because I'm going to use the WebClient. And that's basically it. We could always add other functionality later, but at the moment, that's enough. So let me just create the app. The next step is to take a look at the requests and responses and see what they look like. Now, the first thing I actually have to keep in mind is that I need to authenticate on every request. And the authentication is done through the OpenAI API. You go ahead and register and get a key, and with each request, I'm going to have to submit this authorization header with my OpenAI API key. Go ahead and register a key, and then what I recommend you do with it is to set it as an environment variable on your system. To demonstrate that we can get there, let's start with the models. Find out what models are available, like ChatGPT or GPT 3.5 Turbo or GPT-4 and so on, that are provided by OpenAI. A model object has an ID this object, which is always model, so that's not terribly useful, a created date that's a Unix timestamp as an integer, and then an owned by string to say who owns the model, which is almost certainly going to be OpenAI. So the only thing we really want out of this is the ID, but it couldn't hurt to build a Java record to hold all 4 pieces. Then, in order to list the models, you send a GET request this time to the base URL with authorization header. And you get back a response that has an object which says list, and then data, which is a collection of those model objects. Let's take a look and see how this is going to map to what we need. Here's the record that I put together that maps to the response that comes back from that model's endpoint. I don't have to submit any data, it's just a GET request. This time what I'm going to get back is a model list. This is one way to handle it when you get back a collection. The model list has an attribute called data, and that's the one I want. That's the list of model objects. Model itself is a simple record that has the ID, the created Unix timestamp in it, and that owned by string. Now again, I don't really care about the owned by string, but just for the record, no pun intended, sorry, I decided to deal with the fact that this is camelCase in my Java code, but snakeCase in the JSON data by adding this JSON naming annotation to automatically convert snakeCase into camelCase. I'll need that on the records that are involved in that camelCase to snakeCase transformation. In Spring with POJOs rather than records, I wouldn't need to do that. There's one setting I could set that would convert it everywhere. But I like using records. It's easy when you have RESTful web services, so I don't mind adding the annotation one by one. At any rate, there are the 2 records I need. I'm going to get back a model list, and then I'm going to interrogate for the model, and it will automatically give me immutable objects, a toString, an equals, and a hashcode method. Let's take a look at how we access it now. To access the endpoints in the OpenAI API, I'm going to use this HTTP interface mechanism introduced into Spring 6. The idea is to provide a series of HTTP exchange interface methods on an interface. The beauty of this approach is that once you've set up the web client bean, then all you have to do is add another method to the interface and all the code is generated for you. Let's take a look at that in our application. What I have here is an interface called OpenAI interface. I annotated it with @HTTP exchange because all of the URLs we're going to want to access start with /version1. Might as well have that in the base. Then to list the models, I'm going to get back one of those model lists we just talked about. And there's the URL I'm accessing. That's the actual endpoint. I set the accept header to application/JSON, even though technically that's not really required. I think that's all that endpoint returns, but it couldn't hurt. Now, in order to make this work, I do need to configure a web client. So I've added a Java configuration class. It's a class annotated with @configuration that configures a couple of beans. One of them is the boilerplate that I'm going to need to get back my OpenAI interface. It takes a web client, it uses this HTTP service proxy factory to build a web client adapter for client on that client. I set up a timeout for a couple of minutes. I don't want it to time out too quickly, especially later when I'm generating images or text. And then built it and then called create client and return that interface. Now remember, the other part I have to deal with is that authentication header. So here in my create web client method, the bean method, I'm going to annotate the base URL with that value and the API key. This will retrieve my OpenAI API key from the environment automatically. I don't have to do anything special for that. This one I need to add into application.properties. Here in the builder part of web client, I set the default header to have the authorization with the bearer and the API key in there as a formatted string, set the base URL to the base URL, and we are basically good to go. Next, I need to run a test to see if this works. Here's my application.properties file. I did set the logging level to debug just because I'd like to see the requests and the responses going back and forth. And here is that base URL to reach the OpenAI APIs. It's at api.openai.com. And then here is my test. It's a regular Spring Boot test. I auto-wired in the OpenAI interface. And then I'm going to do two different lists for those models. One is to grab all the models and then navigate down to the data property of that list. That returns the list of model items themselves. I'll turn into a stream, map to their IDs, and print out the IDs so we can see them all. Then, just for fun, I'm going to get them again, and this time I'm going to look for just the models that have the ID GPT inside. So let me run this test and show you the results. This took remarkably little time and just a few hundred milliseconds, and you can see there are all of my model IDs printed out to the screen, and I believe there's about 60 of them. If you look at just the GPT models, here I'm printing out the entire model but filtering it by the ID, partly so you could see the GPT 3.5 and GPT 4 models that are available, also so you could see that our conversion from camelCase to snakeCase did in fact work, because this value is in the snake case and we managed to insert it into the camel case. These Unix timestamps could be converted into something more usable, but at the moment I don't really care much about them. So I just wanted to show you this worked. And the fun part is I wrote very little code. Let me remind you, all I have is this interface with a single method in it, and I have a Java config file that sets up the web client with the authorization header, and then this boilerplate to automatically generate the interface based on that web client. Now it's time to go on and work with the ChatGPT part of this.
Tech dose that never ends.